Open a lush alien forest. At first glance, this planet looks completely normal. Towering forests, dense wetlands, entire ecosystems stretching to the horizon. But there is one thing missing. The sun is not feeding any of it, because on this world, photosynthesis never evolved. No leaves capturing sunlight, no grasslands powered by solar energy, no plants as we know them. Instead, every living thing ultimately survives on chemistry alone. And that creates one of the strangest biospheres imaginable. Life requires energy. On Earth, most of that energy originates from sunlight. Plants convert photons into chemical fuel. Animals then eat the plants, and predators eat the animals. Remove the sun from that equation, and the entire food web collapses, unless another source replaces it. Deep beneath Earth's oceans, such a source already exists. Hydrothermal vents release hydrogen sulfide, methane, and other chemicals from the planet's interior. Entire communities survive around these vents without sunlight. Tube worms, vent shrimp, giant clams, all supported by chemosynthetic bacteria. Instead of harvesting light, these microbes harvest chemical reactions. But there is a problem. Vent ecosystems are tiny compared to forests. So how could an entire planet scale this up? Imagine a world with constant volcanic activity, massive fault systems, crustal fractures leaking chemicals everywhere. Now chemosynthetic organisms can spread across continents, but they wouldn't look like Earth plants. Leaves would be useless. Instead, the dominant plants might resemble giant living chemical reactors. Their bodies could be packed with porous chambers. Inside those chambers live trillions of symbiotic microbes. These microbes process sulfur compounds, methane, hydrogen, and other geological fuels, rather than roots absorbing water. Their root systems might actively seek underground chemical deposits, almost like mining operations. Some species could develop enormous chimney-like structures, pulling gases upward through internal channels. Others might resemble giant fungal towers, covered in vents and breathing pores. Entire forests would constantly exhale strange chemical fogs, making them feel more like living factories than trees. But even these organisms face a problem. Chemosynthesis is inefficient. Much less energy is available than sunlight provides. So many species would need a second strategy. Predation. On Earth, some plants already supplement their nutrition by eating animals. Venus flytraps, pitcher plants, sundews. On this planet, that trend could become extreme. Entire forests might hunt. Imagine a tree-like organism. Its upper structure performs chemosynthesis, but beneath it hangs a network of sticky feeding tendrils. Small animals become trapped, dissolved, and absorbed directly into the organism's tissues. Larger species might evolve pitfall structures several meters across, functioning like gigantic living pitcher plants. A forest here would not simply grow, it would feed. The animals would be strange too. Herbivores would no longer graze on leaves. Instead, they might harvest microbial tissues, chemical nodules, or nutrient-rich reactor chambers. Predators would follow. Entire food webs emerging from geological energy. Volcanoes become the equivalent of sunlight. Fault lines become fertile farmland. And regions lacking chemical activity become biological deserts. Life would cluster around the planet's wounds, not its brightest places.